Hey students, Miss Wallace here. I want to talk to you a little bit about mixtures and solutions. So, we've been studying properties of matter, so we need to take a little bit closer look when we start talking about the property of solubility. And we know that that's when one substance dissolves in another. So, that brings us to our mixtures and our solutions. So, mixtures is going to kind of be your overall main term that everything is going to fall under because a solution is actually just a special type of mixture. But let's start over here on the mixture side. And I'm going to fill in some information that I also want you to put on your anchor chart. So, a mixture is simply two or more substances mixed together. So, say for instance, you had Lucky Charms for breakfast. Those Lucky Charms, you have the little cereal pieces and you have the little marshmallows, and then you put them in milk, right? So, that would be considered a mixture. We know that these can be easily separated. So, let's say that I don't want any more marshmallows. So I could just pull those out of my cereal, right? Or for some of you, you'd rather have the marshmallows, so you pick around the little cereal pieces and you just eat the marshmallows. Another thing with mixtures, each substance keeps its original shape. So with that, with our Lucky Charms example, the little cereal pieces keep the shape of their little cereal. The marshmallows keep the shape of their marshmallows. So that is going to be a property of a mixture. You could also think about, let's say that you have a mixture of iron filings and sand. So those two are not going to, anything's going to not dissolve together. So they're going to keep their own properties. So the iron filings would stay iron filings and the sand would stay sand. Okay. And then last one here, you can separate each substance based on their original physical properties. So the iron filings, for example, are going to stay magnetic because they are made of iron. And the sand, we know if you put it in water, it's going to sink. But you could easily separate those. Okay. So let's put some examples down here of mixture. For some of you, maybe you've had spaghetti and meatballs, right? So you can consider the sauce on there, the noodles, and the meatballs. That would all be a mixture. We talked a little bit about sand and water. Sand is not soluble. It will not dissolve. It's just going to sink to the bottom of the water. So you could easily just pour the water off, or better yet, pour that mixture through a coffee filter, and it's going to keep the sand in the coffee filter and allow the water to go through. How about trail mix? Some of you may like to eat trail mix for a snack. That's a great mixture. I know sometimes I'll get trail mix and maybe I don't feel like eating the peanuts that day. So I could just pick around the peanuts. So remember, that's characteristic of a mixture. You can easily separate the things. And another one that's going to be important to remember is oil and water. Those do not mix. The oil and the water are not miscible, meaning they don't mix together. The oil is actually going to float on the water, and that's because it is less dense. Okay, so that's also part of a density test there. So those are just some examples of mixtures. So let's talk about solutions. Remember, this is going to be a special type of mixture because we have two or more substances mixed together, right? Which was the definition of a mixture. Same thing with a solution, two or more substances that are mixed together. But it's just a special type of mixture. So this is where the substances cannot, let me put that in all bold caps here, cannot be easily separated. So it's not as simple as just picking the peanuts out. And the combination of the substances creates a new substance. And so we're going to use, let's use Kool-Aid as our example here. So we know we have our Kool-Aid powder, we have sugar, and we have water. Once we mix all of that together, we know the Kool-Aid powder and the sugar are going to dissolve, so they are soluble in water, which gives us a whole new product. It gives us the Kool-Aid, whatever flavor you're making, if you're making fruit punch Kool-Aid. So it's not going to be easy to separate those because we have something dissolved in another. So one substance dissolves. I'm going to put that in all caps if I can spell it right, because that's going to be characteristic of a solution. And you're going to notice that when we talk about, we call them solvents. And so a solvent is what you're dissolving your solute in. And so water is our universal solvent. And so we pretty much put anything and everything in water. If it is soluble, then it will dissolve. Okay. So let's go down to some examples. We'll talk more about solvents and solutes later on. So I filled up my hummingbird feeder yesterday, and in there I mixed sugar and water, right? Because the little hummingbirds like to have water to drink, especially on hot days, but they also need energy, so they get that from the sugar. Maybe some of you drink some lemonade, so that would be considered a solution. Here in the winter, maybe you like to drink hot chocolate. And one thing that we know we have a lot of on Earth, 70% of the Earth is covered with water, and 97% of that water is salt water. So salt and water is a solution. So in order to separate a solution, you're going to have to evaporate. So I'm going to add a little text box right here next to these. And I'm going to put in all caps, evaporate to separate. That's how you get your sugar or your Kool-Aid mixture, whatever you've dissolved in the water. That's how you get it back. So let's just use our simple example of salt water. I can put my salt water solution in a pot, put that on the stove, heat it to boiling, and evaporate the water off of that solution. And all you're going to be left with is salt. You could do the same thing with sugar. You could do the same thing with hot cocoa, Kool-Aid. You would be left with your Kool-Aid powder and the sugar. The water is going to evaporate. That is the only part that will evaporate. So I hope this helps you. We're going to be studying more about mixtures and solutions, and I'm going to give you some ideas of how to do a really simple lab next week. All right. Have a great time.